Hi everyone. So today we're going to look at this TEVETA engineering science past paper that was written in 2019. So it was his craft certificate in automotive electrical, as you can see here. So craft certificate is level 4. Then engineering science was written in 2019 November December exam. So let's quickly go through some instructions and see how we can respond to some of the questions here. So instructions to candidates. Instruction number 1, write the exam number or the examination number and the national registration card number on the answer book provided for you. Number 2, there are 8 questions in this paper. Attempt any 5 questions of your choice. Cell phones and programmable calculators are not allowed in the examination room. Acceleration. So this one is very important. Always check for this. So acceleration due to gravity should be taken as 9.81 meters per second squared. Okay. So let's just go through the whole question paper and see. So we should have 8 questions in this one. So question 1, okay, and then question 2 there. So each question should carry equal mark, which should be 20 marks, since we're supposed to answer any 5. So 20 marks, and then 20 times 5 should give you 100. So question 2 there. Then question 3, question 4, 5, question 6, question 7, and question 8. So 5, 5, 5, 20. Okay, so question 8. Okay, so let's quickly go to question 1. So here we have a table. So it's important to. Okay, I'm just going to be dealing with mostly I'll be dealing with calculations because the definitions and these some of the questions can be you can even try to Google, you just do a research in books, you'll be able to find them, but mostly the challenges are on the calculations part. So I'll just quickly go through some of the calculations in the question paper, and then we move on so that we just see what is expected or what is required of us as we handle calculations. So question 1 says copy and complete the table. So this table here is a table of physical quantities and their basic units. So here we have velocity, we need to write the unit for velocity, and then here we have the unit, we need to write the quantity, the length there, we need to write the unit, just like that. So there's already a guide, it's just a matter of writing what we need to write, just to fill in the blanks there. So for example, here on velocity, we know that velocity is measured in the basic SI unit for velocity is supposed to be meter per second. So meter per second, or maybe you write it in full, meter per second, like that. So this one is meter per second squared, or meter per square second, meaning they're talking about acceleration. So meter per second squared is supposed to be like this, meter per second squared, like this. So here means they're talking about acceleration. So we know that acceleration is measured in meter per second squared. Oh, sorry about that. So acceleration, okay, here we have meter or meter, like that. So this is the length or the distance. So meter, excuse me. And then here we have the joule. So joule, energy is measured in joule. Can also be work done, but normally work done is measured in Newton is it Newton meter? Okay, so joule is just the energy there. So energy, and then pressure is measured in Pascal. Or just Pascal like that. So watt, it's power. Okay, so that's how you complete the table. And then B says convert the following. So from the first one is saying 50 meters to nanometers. So we have to understand that one nanometer. Sorry about that. So 1 nanometer is equivalent to 1 times 10 power negative 9 meters, like that. So for this one, we can we can write it here. So 50 meters to nanometers there. So here we can start with the conversion from so we know that 1 nanometer is equivalent to 10 power negative 9 meters. Okay, so like that. So here we are looking for value in nanometers, so we are going to put 50 here meters, and then x here in nanometers, like that. Okay, and then we cross multiply, so we are going to have 50. Okay, so whatever is here will cancel, so we're going to have 50 times this, so it will be 50 nanometers is equal to x times that will be 10 power negative 9 x. So meaning here we will divide over 10 power negative 9, even here over 10 power negative 9, and then whatever is here will cancel, then our x will equal 50 times 10 power 9 nanometers. Okay. The second one is 0.8. So this one here, which is 0.8 kilometers. So 0.8 kilometers to meters. So 0.8, we know for sure that kilo means 10 power 3. So this can also be rewritten as 0.8 times 1000, which is 10 power 3. So this is in meters now, because 1000 means a kilo. So we've got rid of the kilo by putting the value for the prefix, because kilo, we're saying kilo is a prefix, so we've put the value for the prefix there. So this one has to be converted to millimeters. Okay, so you know that 0.8 times 1000 is the same as 800 meters. Also this is B. And then we have A there. Okay, so B. Okay, B. So this is question B, and so this is 1, and then here we have 2. Okay, so here we know that 800 is the same as 0.8 kilometers, so we convert to millimeters like that. So even here we know that 1 meter is equivalent to 1000 millimeters, meaning 800 meters will be equivalent to x, and then when we cross multiply, we're going to get x is equal to this one and this one. So x is equal to 1000 times 800, which will be this 800,000. So this should be in millimeters. Okay, and then we have question 3, where we have 50 kilometers per hour. 50 kilometers per hour to meters or meter per second, like that. So even this one, we just change kilometer in terms of meters, so we know that this kilo is a prefix, so we can just convert it to the numerical value, which is 1000. So it will be 50 times 1000, which is 50,000. So 50 times 1000, so times 1000 meters. Okay, and then over, so this slash means over, and then 1 hour has to be converted to seconds. So how many hours are there, how many seconds are there in 1 hour? It's 3660, so 3600 seconds, like that. And then these are going to be, so it will be 500 over 36, and then 500 over 36 will give us some, let's see on the calculator here. We have write it here, which is 13.8, so this is in meter per second. Okay, the last one, which is question 4. So question 4 there, we have 26 millimeter per minute to meter per second, Okay, so this one, we know that milli is a prefix which means negative 10 power negative 3. So this is the same as 26 times 10 power negative 3. This is in meters over minute to second. We know that minute is 60 seconds, so over 60 seconds. That, so which will give us, so let's just punch this on the calculator and see what we get. Okay, so we have 26 times 10 power negative 3, which is that, and then divide 16. Okay, so this will give us that, which can be 4.3 times 10. So this one here will be 4.3 times 10 to the power negative 4. So this is in meter per second. Okay. Question 2. So says an 80 Newton floodlight is suspended from 2 wires which make angles of 20 degrees and 30 degrees with the horizontal as shown below in figure Q1. Determine the tensions T1 and T2 in the wires. Okay, so we have a diagram here. We have a diagram. So what's important here is to understand the forces that are acting. So in order for us to do that, we're going to draw a free body diagram. Okay, so here we have a force going in that direction at an angle of 20 with the horizontal, so this is T1, and then we have another one going in that direction, which is T2, and then we have the weight. So the weight has to be a vertical line, okay, something like that, which has been given there as 80 newtons. So now, analyzing this diagram here, we know that if we have 20 here, and then this force here, the weight force, is always at 90 degrees with the horizontal, so we can work out the entire angle that is here, which will be 20 plus 90 here, so meaning here we're going to have angle 110 110. Then here it will be 90 this side plus 30, so we're going to have 120 here, and then angles on a straight line on the horizontal there, they always add up to 180, so 180 minus 20, that will be 160, and then minus 30, that is here, it will be 130. So here on top we're going to have 130. So these angles are like this. And then since we have 3 forces that are acting, we can use what is called Lami's rule. So using Lami's rule, So according to this rule, it says x over sine of the opposite angle, which is c, opposite to that force that is acting, which is c. So x over sine c is equal to y over sine b which is also equal to z over sine a, like that. So we can use this formula to find these forces that are here. So for example, we can pick A2. We already have this one, which is known, and one unknown. So for us to solve for T1, we're going to have T1 over sine of the angle that is opposite to T1, which is 120, is equal to 80, which is the weight, over the sine of the angle, so over sine 130. So we can make t the subject of the formula. When we cross multiply, we're going to have T1 equal to 80 times sine 120 over sine 130. That, then punching this on the calculator. So our final answer here will be equal to 90.44 newtons. Okay, so for T2 we'll do the same. So T2 is opposite to 110, so we're saying T2 over sine 110 is equal to 80 over sine 130, meaning T2 will equal 80 sine 110 over sine 130. So T2 will equal, so let's punch this on the calculator. So we have 80 sine 110 divide sine 130. Okay, so we have 98.13. So we have 98.13. So T2 is 98.13 newtons. Those are the values for T1 and T2 there. So let's look at question 3 now. So question 3C here says a force of 15 newtons is applied to a spanner at an effective length of 140 millimeters from the center of the nut. Calculate, number 1, the moment of the force applied to the nut. Okay, so this one we know that okay, first of all, we've been given the force, which is 50 newtons, 50 newtons, and also the length, which is the distance, which is 140. So 140 millimeters has to be converted to 140 millimeters, but we know that millimeters has to be converted to the SI unit for length or distance, which is meters, and we know that the milli is 10 power negative 3, so it is 140 times 10 power negative 3, so this is in meters now. Okay, and then they are asking us to find the moment of the force. So here moment is equal to force in newtons times the distance in meters, which will be, so the force is 15 newtons times the distance is 140 times 10 power negative 3, so this is in meters now. So our answer there will be 2.1 Newton meter. Okay, like that. And then the second question says the magnitude, so calculate the magnitude of the force required to produce the same moment of the effective length is reduced to this. I think this one is supposed to be if. Let's take note of this one. I think it's supposed to be if, not of. If the effective length is reduced to 100 millimeters or 100 millimeters. So we go back to the, so here what we've been given, so in the second case there, what we've been given is this one was number one. So for number two, what we've been given is we have the moment. So the moment is this one. So we've been given the moment, which is 2.1 Newton meter, and then we've also been given the length, which is the distance. So it's saying the length has been reduced to this, which is the same as this, times 10 power negative 3 meters. And then they're asking us to find the force, the magnitude of the force. So this one we don't know. So we go back to the same formula. We know that moment is equal to force times distance. Only that this time we've been given the moment and the distance, so we are looking for the force. Okay, so the moment is 2.1, which is equal to the force we do not know, times 100 times 10 power negative 3. Okay, and then making force the subject of the formula, so we just do over this, even here, over the same. Okay, so force is equal to, was this and this will cancel, so force is equal to force will be 21 newtons. Okay, so question D here says metal bar AB is 4, so I think this one is supposed to be 4.0 meters long, 4.0 meters long, and is supported at each end in a horizontal position. It carries loads 2.5 kilonewtons and 5.5 kilonewtons at distances of 2 and 3 respectively from A. Neglecting the mass of the beam, determine the reaction of the support when the beam is in equilibrium. Okay, so for this one we can start with a diagram. Let's put up a diagram. Let's put up a diagram here. The beam is said to be in equilibrium, meaning we have to use the two conditions for equilibrium. So the two conditions for equilibriums right here. So we can say we know that number one should be the summation of all forces. So in this case, all vertical forces should equal 0, and the other one should be the summation of all moments should equal 0. So for the first one here, we need to identify all the forces. So first of all, let's write the free body diagram and see. We can draw a free body diagram and see the forces that are acting there. So we have the beam, we have a support reaction here, which is reaction at A. So we can call this one RA, and another reaction at B, we can call this one RB, so reaction at B. And then let's have a force there, which is 2.5 kilonewtons, and another one there, which is 5.5 kilonewtons. So the distance here is 2 meters. Here it's 1 meter. Okay, remaining with 1 meter there. So the total span is 4 meters. Okay, so using the first condition, this one here, we add all the forces that are acting there. So we can start, all the forces that are going up will be to the left, and then the forces that are going down will be to the right, or maybe we can just equate them to 0, whichever the case. So here we can say RA is going up plus RB equals all these that are coming down. So we have 2.5 plus 5.5, like that. And this one is going to be RA plus RB equals 2.5 plus 5.5 will give us 8. So equals 8. These are kilonewtons, so 8 kilonewtons. That is our equation number 1. And then from the same diagram here, we can go to the second one, which is the summation of moments. So taking moments at A, we can have so clockwise moments will be to the left, and then anti-clockwise moments will be to the right. So here we can say taking moments at A, taking moments at this point. So the moment for this one will be, so the clockwise moment will be to the left. So we're going to have 2. So moment is supposed to be force times distance. So it will be 2.5 times 2, which is the distance from this point to that point, plus 3. So the distance from this point will be 2 plus 3, so plus 1, which is 3. So 3, so 5.5 times 3. Okay, and then this one will be negative, so it will be negative, so minus RB times 4. So this should equal 0. Okay, and write it here. So 2.5 times 2 will be 5. So we have 5 plus 5.5 times 3. So this is 16.5. So this is 16.5. So 16.5 minus 4RB is equal to 0. And then we solve for RB. So this plus this will give us 21. Is it? Yes, so this one will give us 21.5. So 21.5 is equal to, so if this one goes this side, will be positive 4. So positive 4 RB. And then over 4 over 4. So this one and this one will cancel, and then our RB will equal, 5.4 newtons. 5.4 newtons. And then coming back to this equation here, we know our RB now, so we're going to have RA plus 5.4 is equal to, this one is kilonewtons, not newtons, so kilonewtons. And then here we're going to have RA plus, so RB is 5.4 kilonewtons is equal to 8 kilonewtons. In our RA will be 8 kilonewtons minus 5.4 kilonewtons. So RA will equal 2.6 kilonewtons. So that is our reactions at A and B. Okay, so let's look at question 4. So we go straight to the calculation, which is B. So B. So we go straight to the calculation, which is B. So we go to question B here. So this one says a force of 1200 newtons acts on a motor vehicle of mass 3500 kg. It causes it to maintain to maintain a constant speed of 15 meters per second for 20 seconds. Determine the displacement covered in 20 seconds. Okay, so for this one, we've been given a constant speed of 15 newtons. So whenever you've been given a constant speed, the formula that you use is V is equal to D over T, or S over T for constant speed. It's a constant speed. So from here, what have we been asked to find? The displacement, which is D. So it's just a matter of making D the subject of the formula. So displacement will equal V times T, and then we know that the velocity is 15 times the time, which is 20. Then our distance will be 20 times 15 will give us 300 meters. Okay, and then so this is B1, and then B2, and then B2 will be determine the work done. So the work done, so work is equal to force times distance. Okay, so the force has been given here. The force is 1200 newtons, and then times the distance that we are just from calculating, which is 300 meters. So here, if we multiply those two, we're going to get 12 times, so it's 36. Okay, so if we multiply here, we're going to get 36 okay, so we're going to get something like let's just confirm on the calculator. So 1200 times 300, so what do we get? Okay, so this is supposed to be in joules. Okay, so the next one is the kinetic energy developed. So for kinetic energy, we have so this is question 3. So we know that kinetic energy is equal to half times the mass times the velocity squared, or the square of velocity, and we have so half times the mass is 3500 times our velocity is 15, and then squared like that, meaning we are going to have 35 times 225 everything over 2, which is equal to 30, which is equal to, so we have 3500 times 15 squared, which is that, and then divide 2. Okay, so we have 39, 37, 50. So energy is measured in joules. Okay. last one is the power developed. So power is equal to work over time. So this one will give us the work. It's that one there in joules. So 36000. So over the time is 20 seconds, which will give us 18,000 watts. Okay. Okay, so let's look at question 5b. So as usual, the first ones are definitions. And, let's look at B. So question 5b here. So it says a motor vehicle starts from rest and accelerates to 30 meters per second in 25 seconds. Calculate the acceleration. So here, let's see what we've been given. So it starts from rest, so meaning u is equal to 0, and then accelerates to 30 meters per second. So note that it's saying 30 meters per second, meaning it's the velocity that you've been given there. So final velocity is equal to 30 meters per second in 25 seconds. So time is 25 seconds, like that. Then calculate the acceleration. So we know that from this equation, the first equation of the Subad equation, so V is equal to U plus a t. We can make t the subject of the formula there. So V is 30, so we have 30 is equal to U is 0 plus a times t, which is 25. Okay, so here we have 25a equals 30, and then over 25 over 25, which gives us a equal to 1.2 meters per square second. Okay, and then the other one says the displacement covered. So number 2, the displacement covered during 25 seconds. So the displacement covered during 25 seconds, we can use the other equation. So B, we can use this equation. So S is equal to U plus V over 2 times time. So S is equal to, so U there is 0 plus V is 30. So everything over 2 times T is 25. So times 25. Then S will equal 15 times 25, which is equal to 15 times 25 is equal to 375, equal to 375. meters. 375 meters. Okay, and then let's look at question C. So question C is, according to the highway code, a car traveling at 72 kilometers. So a car that is traveling at 72 kilometers means initial velocity is 72 kilometers per hour, which can be converted to meters per second. To start with, we convert that one to meters per second, which is the same as 20 meters per second. So we can traveling at that. Requires a minimum braking distance of 30 meters. So the distance is S is equal to 30 meters. Okay, so if it requires a braking distance, meaning from that, if you apply the brakes, it has to come to rest, meaning the final velocity, V has to be 0. That 30 meters. Then determine the standard retardation. So retardation is just acceleration, which is negative acceleration. So okay, so for this one we can use this equation to find the acceleration, since we do not have time. So we can use this one. V squared is equal to U squared plus 2AS. So we just have to make the acceleration subject to the formula, but we can substitute. So we know that V is just 0, so 0 squared is just 0, is equal to U squared is 30 squared, which is 900, plus 2 times, so S has been given, which is 30, 2 times 30, and then times A there, which is that one there. So here we're going to have 0 is equal to 900 times 60A. And then 900 can go outside, or maybe we're going to take this one. That's it. So we're going to have negative 60. A is equal to 900 over negative 60 over negative 60. So this one and this one will go. So A is equal to 900 divided 60. So we're going to have 900 divide negative 60 there. We have 15 negative. So our acceleration is negative 15 meters per square second. Okay. The next question says the stopping time. Okay, so for the time we can use the so this is question 2, time. So for the time we can use this equation. S is equal to U plus V over 2, and then times T. Then S, we already have S, which is 30, is equal to U is 20, so 20 plus v 0, and then over 2, then times time. So we have 30 is equal to 20 plus 0 is just 20, and then 20 over 2 will be 10. 10 times 2 is 10t. So 10t, and then over 10, over 10. Then our t will equal 3 seconds. 3 seconds, like that. Okay, let's look at question 6b. So question 6b. Calculate the force that a 70 kg man exerts on the floor of an elevator. One is when it ascends with a constant speed of 1.2 meters per second. Okay, to find the force, so to find the force here, we use Newton's second law, which says force is equal to mass times acceleration. Now when you look at the first case there, where it says it ascends with a velocity, a constant velocity of 1.2 meters per second square, if the velocity is constant, then the acceleration, there is no acceleration, meaning the acceleration is 0. So this formula will just be force is equal to mass, which is 70 kgs, times 0, which is just 0. So the net force will be 0 there. And then the second one says, so here we can put since velocity is constant. Since velocity is constant. Okay, so for the second one, so this one is saying calculate the force that a 70 kg man exerts on the elevator when it descends with a constant acceleration of 2 meters per square second. Okay, so for this one, since it's going in the downward direction, then the acceleration will be negative. So Newton's second law will be used in on this one. So we know that force is equal to mass times acceleration, and the force will be equal to mass, which is 70 kgs, times the acceleration will be negative 2 meters per second squared. Okay, square second. Okay, and then the force will be negative 140 newtons. So this means the elevator is going in a downward direction. The third one, when it ascends with a constant acceleration over, so again, even here, Newton's second law will be used, but since it's going up, meaning the acceleration will be positive, so it will be 70 kg times 2 meter per square second. So this will give us 140 newtons positive, and it is going up. Okay, let's look at the other one. Okay, so question 7, let's look at part C. Question 7C. So what have we been given? So here it's saying calculate the amount of heat required to raise the temperature of 3 kg of aluminum from 20 degrees Celsius to 110 degrees Celsius if the specific heat capacity of aluminum is or for aluminum is 800 K. So I think it's supposed to be kilojoule, or maybe it's just supposed to be joule. Not sure. So it's supposed to be joule per kilogram. So the specific heat capacity is joule, 800 joule per kilogram. So we will use joule. So what we've been given here, we have the mass. This is equal to 3 kgs, and then we have the temperature. So we have T1, which is equal to 20 degrees Celsius. We have T2, which is 110 degrees Celsius. Okay, and then we have the specific heat capacity C, which is equal to 800 joule per kg. Okay, so here we've been asked to find the amount of heat required, which is Q. We use this formula. Q is equal to MC delta T, which is the change in temperature. And we know that change in temperature is equal to T2 minus T2 minus T1. And then so this will equal 110 minus 20. So this one is equal to 90 degrees Celsius, which is the same as 90 kelvins. Okay, and then our Q here is going to be, so the mass will be 3 kgs, and then times the specific heat capacity, which is 800 joule per kg, times 90 K, and then Q will equal, what do we have here? So we can have 3 times 800 times 90. Okay, so we have 216,000. So that's our joules, or simply 216 kilo joules, like that. Okay, let's look at the last question, which is question 8. Question 8. So this one is saying a particle is thrown vertically upwards with a velocity of 50 meters per second. If the air resistance is ignored, determine maximum height reached. Okay, so here, we know that first of all, we can have a particle there. So this one is thrown upwards like that, so it follows that path. So at this point we have an initial velocity u. So at this point we have an initial velocity u, let's write it there, which is 50 meters per second. So this is the direction, and then at that point the final velocity will be 0, so that is at the maximum height. And we know that the acceleration here is acceleration due to gravity, which is always negative 9.81. Okay, and then they are asking us to find the height, so we don't have the height and the time taken. We don't have the height and the time taken. So let's look at the first question where we asked to find the height. So the maximum height will be given by we can use this formula. So v squared is equal to u squared plus g h. Then we make h the subject of the formula. So we know that v is 0 is equal to u squared. Sorry about that. So u is 50. So 50 squared, and then plus g, and then we know that g is negative 9.8, so 9.81, so negative 9.81 times h. So h there. Then we can take this one this side. So 50 squared is equal to 2500. Okay, so we can take this one this side, or maybe we can take this one this side, so that we have 9.81 h. So the sign will change here, since it was negative, so it will be positive, is equal to 2500, and then over 9.81 over 9.81, like that. So our h will equal that divide 9.81. Okay, so that is about 250. Okay, so we have 254.84. So 254.84 meters. So 254.84 meters. Okay, and then the time. So number 2, the time. So for the time, we can use the equation v equals u plus a t. So we know that v is 0, and then equals u is 50 minus the acceleration is g, so minus 9.81 times t, and then when we take this one this side, we're going to have 9.81 t is equal to 50 and then over 9.81 over 9.81. So our T will be 50 divide that. So 50 divide 9.81. Okay, we're going to have that. So 5.1 seconds. Okay, so that is our T. Okay, so part B. A load of mass 50 kg is positioned at a height of 100 meters above the ground. If it is allowed to fall freely and air resistance ignored, determine number one, the time taken for the load to fall to the ground. Okay, so here we have a body, and then it's allowed to fall freely to the ground. So at this point, the initial velocity will be 0. Okay, and then the height is 100, and then we have the velocity there that we do not know. What else have we been given? Okay, we know that the mass is 50 kgs. Mass is 50 kgs. Then looking for the time. So for the time, we will use this equation. So we have S is equal to UT plus half AT squared. And this one is H, this one is G, which is negative 900. So here we can even put gravity. So G is equal to negative 9.81 meters per second squared, like that. Okay, so now here, since the body is moving from the top going down, or it is moving in the negative direction, meaning the distance will be gotten as a negative. So in this equation, we're going to have negative 100 is equal to U is 0 times T, which is 0. The whole lot of this will be 0 there, plus half. So A will be gravity, which is negative 9.81, and then times T squared. So here we're going to have negative 100 equals 9 over 9.81 over 2 will give us, so 9.81 divide 2 or times half will give us 4.9. Okay, so negative 4.9 there. So we're going to have negative 4.9 T squared. Okay, and then over negative 4.9 over negative 4.9. So this one will cancel, and then here we're going to have 100 divide negative 4.9, divide answer will give us 20.5. 20.4. So t squared is equal to 20.4, and then t will equal square root of 20.4, which is equal to, so t is equal to, what is the square root of that? So we'll say square root of answer, which is 4.5. This is 4.5. So we're going to have 4.5 seconds. 4.5 seconds. For the next question, which is question 2, we can use, so if the body is moving the free fall, down like that, turns out at this point the potential energy is 0. At this point the potential energy is high, because it is at the highest height, and then the kinetic energy is 0 because the velocity is 0 at this point. So when it reaches that point, as it lands, you have the highest kinetic energy, and then the potential energy is at its lowest because the distance is 0. Right. So this means the potential energy at this point is equal to the kinetic energy at that point, and the kinetic energy at this point is equal to the potential energy at that point. So we can use this equation to find the velocity. We can say kinetic energy is equal to potential energy. And we know that kinetic energy is equal to mass times velocity squared over 2, which is equal to potential energy is equal to mgh. So the mass is the same. Okay, then we are remaining with this. So if we cross multiply there, we're going to have v squared is equal to 2gh, and then square roots on both sides. We're going to have v equals 2g square root of 2gh. So v will equal the square root of 2 times negative 9.81 times, and since we are coming from the top going down, meaning even the height will be negative 100. Square root of all this, then our v will equal 2 times negative 9.81 times negative 100. So we have that, and then square root of answer, going to have that. So this will give us 44.29, or 44.3 to 1 decimal place. So this is meter per second. Okay. Or we can use this formula. We can use this formula and use v squared is equal to u squared plus 2as. So now we know that we're looking for v, so v squared is equal to u is 0 minus, since we have this a which is negative gravity, so it will be 2 times 9.81 times minus 100, which is the height. So v squared is equal to negative 2 times 9.81 times negative 100, which is that, and then square root of answer, we have that. So v is equal to 4.3 meters per second. Okay, so that is it up to question 8. And please, if you have any questions concerning the same, make sure that you ask in the comment section. I'll be able to respond. Thanks for watching.